Section 3.1 is dealing with fractions. The top part of the fraction is called the numerator. Bottom part is called the denominator. So if I have 3/4, numerator is 3, the denominator is 4. An improper fraction is going to be the reverse. If I have 4/3, where the top number is bigger than the bottom number. So the numerator is bigger than the denominator. And then last vocabulary, we have a mixed number of 3.5. So we have a whole number and a fraction put together as a mixed number. So the first concept they're really talking to you about are improper fractions. So if I have 1/5, 3/4, 5/3, and 6/5, which one of those are proper, it means they're okay, and then which ones are improper. Well, the improper fractions, remember, are going to be the same or larger than the denominator. So this one is going to be 5/3, it's going to be an improper fraction. This along with 6/5 are both improper fractions, where the top number or the numerator is bigger than the denominator. These are okay, they're proper. So, as we're looking with these then, let's say that we also had maybe 13/13. Okay, this can be reduced. Okay, so how many 13s and 13? 1, as well as these can be reduced. So maybe another way to look at this, if it helps, is they can be reduced or simplified. Okay, the other one is a mixed number. So here, if I have our 3.5 example again, I have 3 groups of 2 because I'm in groups of 2. And then I have 1 left over. Okay. Another way to think of fractions before I leave this concept here is, way to think of fractions really is part out of the whole. So part out of the whole. So if I have 1 part shaded out of 4 parts total, might help to think of it in that term. So let's do a couple of the sample problems in the book as we're looking at our homework here. So let's say that we have number 21. We have 23/6. So that means that we have groups of 6. So how many full groups of 6 are we going to have in 23? Well, if we count by 6s, 6, 12, 18, 24, we don't quite have enough for 4, but we do have enough for 3 groups. So 3 times 6 is 18, so we subtract our 18 from our 23, and we have 5 left over. We're still in groups of 6, so it's 3 and 5, 6. Let's do another one of those. Let's go right next door to problem 22, and we have 31/7. Well, how many groups of 7 are there in 31? Well, if we count by 7s, 7, 14, 21, 28, 35. I don't quite have enough for 5, but I do have enough for 4. And 4 times 7 is 28. We have 31. We're using up 28 with our 4 full groups, and we subtract. So we would have 3/7 left over. Well, how do we do those when they're great big? So let's say we're looking at problem 30 when we have 500/17. Well, counting by 17s is going to take a little while. So I would recommend using a calculator. So I'm going to put it over here where we can see the calculator. And we have 500. And we're going to divide that into groups of 17. Well, notice that there is 29 full groups, and then there's a decimal answer. Those are going to be our remainders or our part. But we really wanted to know how many full groups. So if we then clear that off, we want to know how many we used up. In this particular problem here, we used up 28 with our 4 groups. So we want to know how many we used up when we used up the 29. So we take our 29 full groups times by our 17, and we used up then 493 of our 500. So then we would subtract that. We would have 7/17 left over. So we find out how many we used up, subtract it from how many we had total, and then we have a remainder. Let's do another one of those. Let's do 31 right next door. Get over here where we can see nice and easy. So we have 331, and we're dividing into groups of 15. Again, we're going to use our calculator here. So we're going to take 331, we're going to divide by 15, and we have 22 full groups plus some leftover. This is the leftover. We don't really care about that at this point. We just know that those are the parts. The 22 whole groups is what we do care about. So 22 times 15 tells us we use 330 of the 331 in our 22 groups. Subtract gives us 1/15. And that's how we do that using the calculator with some of these bigger ones. Some of these smaller ones we can probably do in our head to a certain degree, but we can do that the same way. Simply take our calculator, divide by our numerator, divide by our denominator. We're going to get our whole number, factor that back in, do our subtraction, and we have our remainder. Now these are opposite principles here. So if I have 15 fourths as an example, how many groups of 4 and 15? There are 3, and then there are 3 fourths left over because we used up 12 in our full groups. But if we multiply this back through, we have 3 times 4 is 12 plus 3 is the 15. So these are equivalent. They're just written in different ways. This is a mixed number. This is an improper fraction. So with problem number 33, they're asking you to put that back. So you have 5 and 5/7. So this means I have 5 groups of 7. So 5 times 7 is going to be 35, plus the 5 that they had there gives me 47. The one right next to it, problem right next there, is 6 and 7/8. Again, I have 6 groups of 8 is what that tells me. So 6 times 8 is 48, plus 7 gives me 55/8. So these are simply inverse. Okay, they're going back and forth here, doing the same type of concept. Have fun with the homework.